Hello, Assalamu alaikum. So today we are going to discuss the next two properties of the circle. So the first one is alternate segment theorem. So before going to understand this concept of alternate segments theorem, let's understand the basic terminologies. So if we see inside a circle, there is a chord, for example, let's mark it. If I say that A to B, this one, B to B, this line is a chord, right? So this one is a chord, and a straight line which touches the circle at only one point is known as the tangent. So let's say if I highlight this portion, this straight line is basically acting as a tangent to the circle. So this one is tangent to the circle, right? So this theorem is about the angle formed between a chord and a tangent. So we can clearly see here that the chord AB and the tangent line, which is drawn as red, is making an angle Y. So this theorem states that if there is an angle formed between a tangent and the chord, and by joining the same points on the other side, or what do we mean by other side? If we see that these 2 points A and B, and it join and make an angle on the opposite side like this one, from the same points of the chord, then these two angles are known as alternate angles, alternate segment angles, and they are always equal, right? So the angle formed between the tangent and the chord is equals to the angle formed in the alternate segment. So what are the key points here? That the angle has to be between a chord and a tangent, and it will be equals to the angle in the alternate segment. But the main word is that angle has to be formed from chord. So if we are making the angle from the chord, then these two angles will be equal. Similarly, if I erase it and make a relation on the other side like this, that if I see in this diagram that if I take this one as a chord, let's say this one, and I name it as, for example, C to D or C to B, again, there's an angle which is formed between this chord. In this case, I'm considering this chord and the tangent, and the angle formed here is X, right? So again, if I make an angle in the opposite side or in the alternate segment, by joining the same 2 points on the chord, they will be equal. So if this one is X, this one is also X. So this theorem is known as the alternate segment theorem. Okay, now moving on to the next one. It's an intersecting chord theorem. Now what does an intersecting chord theorem means? For example, if there is any chord, let's say I draw a random chord here. Let's say I make this one as a chord and I name it as AB, for example. Now, it says that if there's any chord inside the circle, and from the center of the circle, you draw a straight line. For example, if I make a rough straight line here, like this, so it says that this straight line always makes an angle of 90 degrees on the chord, and it bisects the chord. What does bisects mean? Bisects means that this whole angle was, let's say, 10 centimeter. Now this straight line, which is at 90-degree angle, have bisected, or you can say it have divided the side into two equal parts. So now this side is also 5 centimeter, and from here to here is also 5 centimeter, because this line have bisected the chord into two equal parts. This is known as intersecting chord theorem. So first of all, a chord is a straight line. The straight line connecting 2 points on the circle, and any perpendicular means any straight line which makes an angle of 90 degrees from the center of the circle to the chord. It basically bisects the chord. Bisects means cut the chord into two equal parts. And why it is cutting into two equal parts? Because that line is drawn from the center to the midpoint of the chord. Midpoint means which cuts into two equal parts, and it makes an angle of 90-degree right angle. So that is all about intersecting chord theorems.